I'd like to introduce our next speaker, Jim Olsen. Jim is the CTO of ModelOps, where he leads the technical design of ModelOps Center, the leading ModelOps platform. He is a technical innovator for the past 30 years, leading architectural design for products at a variety of companies, including Teradata, Qualtrics, and Novell. And he also holds 2 software patents. We are very lucky to have him here today, all the way from the Rocky Mountains of Colorado. Jim will be talking about the difference between MLOps versus ModelOps and why you should care. Please give a warm welcome and chat to Jim Olsen.
All right, there we go. Technical difficulties resolved. So let's get going on the presentation here today. As Peter mentioned, my name is Jim Olsen. I'm coming to you from Colorado right now. Yeah, beautiful sunny spring day out here. So we're going to talk to you today a little bit about, obviously this is the MLOps conference, but there's a newer term that's coming up that encompasses very, very, very similar stuff, maybe a little bit broader reach, and that's what we're going to go into today, called ModelOps, where we actually can explain what's going on and what that new term you're hearing about is today. As I said, I work for a company called ModelOps, where we've done a pure play implementation of the ModelOps software, but just today, we're going to be talking generally about what ModelOps is as a whole, rather than anything specific. So just to review, I mean, I'm sure you're all familiar with this, but MLOps really comes from specifically doing machine learning technologies. So the whole idea is, okay, we're going to actually train these models. We want to improve these models over time. We want to make sure they're performing as they should, and create a closed back into the development process to make sure issues as they pop up come addressed. And that's the whole idea of MLOps, but they're very specific to the way that you deal with machine learning models and that kind of thing. So a standardized architecture is kind of a very scripted flow where it deals a lot with the development. We'll talk a bit more about that in a minute, where ModelOps is a little bit later in the cycle, but MLOps around, you get things such as hyperparameter tuning. How do I organize my data? How do I get what data is actually present to put into these models? Is it in the right kind of format for doing labeled training and things like that on that? And then also basically the performance of the model is against the nature of the data it was trained on. How do we compare the difference, and what happens there? And maybe we need to reevaluate the model. And to do that, absolutely, we gather some information about the model, but it tends to be very focused in the machine learning space and things like is it used to train it, or the very specific binary that's associated, like a pickle file, kind of things. And maybe doesn't include as much about the actual source or model documents or things like that. So it's a very targeted platform that really looks at that delineation of how do I get data, train the model, make sure it's doing what it's supposed to be doing, and then know when to readdress the data or the training or that kind of thing, and go on from there and that kind of thing. So that's where our MLOps comes from. Makes out methodology to actually follow to get in there and really get some control on how you're training your models. But then there's really the larger concepts of actually what goes on with a model. Here's a quote from Gardner here, which I won't read it out in its entirety to you, but contrast it to MLOps, which really does talk about ML models specifically, and does a lot of things very specific to machine learning. A lot of businesses have a lot of models out there that are not machine learning. And in fact, from my personal experience, I'd say something like 90% of the models still used in business are not yet machine learning models. Absolutely moving in that direction, and absolutely important in there. They've got all these different models, which I've seen everything from if-then else statements to decision tables to straight traditional logistic regressions, random forests, all kinds of different things where these models are not trained. They don't have that kind of information about the training data associated with it, and you don't really retrain them. You have to do that. So there's a much larger life cycle that actually kind of occurs with these models, where you not only have to worry about training them and developing them, but now we need to actually track what are they doing out there, where did they come from, associated with them, have they been checked against for bias, have they required documents, all kinds of things, which we'll go into more as we go in this presentation. So I just really want to point out that model ops actually includes ML ops, absolutely, but model ops does a whole lot more. Things like that. And so these diagrams on the right, you see in depth, but the idea is we're really running it through an entire business process to make sure that we get models out there in the form that we expect and they perform correctly. So going to show our architecture here of our product to give you an idea of some of the components that likely go into a model ops solution as opposed to an ML ops solution. Our solutions on that kind of thing. So that's what you'll see. The upper left represents kind of the core of a model ops solution that needs to provide a variety of services there. One of the biggest things that it needs to do is it really needs to be this centralized system for orchestrating all of these different business processes that actually need to occur out there in order for a model to be given the vigor and rigor that needs to go into it to make sure that regardless of what's out there. It also is going to, because it's not just a machine learning development environment, which, it's like there are quite a few out there, but still it's a much more contained space than if we actually go into including, you said, things like decision tables, R models, et cetera, that are out there. You're not going to use the same tools to develop a decision table that you're going to use to develop a machine learning environment. So, one of the key things in an architecture of a model ops solution is it needs to work with a variety of different development environments. Because absolutely Jupyter is great when you're doing a Python model, but tons of R models out there, or you may want to do a more of an automated machine learning platform like a SageMaker for your machine learning models, but that isn't going to be your best choice for just writing some simple, straightforward logistic regression in Jupyter. It's not going to it's probably going to be overkill for that situation. So really, when you come to a model ops solution, it needs to all of these different development environments provide a single pane of glass into what's actually going on out there with your models, and do that in a consistent pattern on that. Much like you see with DevOps solutions in the coding space, you wouldn't even think of prescribing a developer must use. In my own development team, I know there's every variety. This writing DevOps solution, ignores those and works with them seamlessly, and that's what you need to do with a model ops solution as well. Key item that's realistic is you're going to need to integrate with existing IT solutions to actually deliver that. We can't really, because we're going across development platforms, we're going across development teams, we're looking at all different kinds of models coming from different places. We need to make sure that these solutions actually do look and integrate with, for example, existing ticketing systems. You're not going to want to go 4 places for all of these different, for all the different human tasks that need to be recorded in doing that. Likewise, you need to do integrations with existing CI/CD environments and things like that as well, and all different kinds of runtimes. It's like you're going to run on Spark for Spark models. You're going to run on SageMaker for SageMaker models. You can't assume that there's one environment that's actually going to do that. So it needs to support those different targets for where these things may run to, and they may run as batch, or they may run as a RESTful deployment that does individual inferences. So we need to be able to orchestrate those kinds of different areas as well is critically important. Likewise, when you get to looking across all of your different models coming from all different platforms, we need to integrate with those reports that are standardized with to be able to provide high-level reports, and we'll go into that a little more detail what that looks like in the end there. But the is to become that conductor of the orchestra across all these different components, all these different model environments, all these different runtimes. We need to provide that process where we move it through no matter where the model is being developed and what kind of things. And that's really a differentiator in model ops, is it doesn't rely on any underlying knowledge about the individual architecture of any given one model. It can orchestrate them and manage them no matter what things there. And then through that, we need to we're creating basically auditable snapshots of these models. So, we have them, immutable once they're created. So when that model goes out there and is making inferences and ever comes back and wants to know the lineage of that model and what it was at that exact point in time, a model op solution needs to provide that. It needs to have something that you can come back to actually prove that out. So, that's actually key within a model ops infrastructure where you may not have that level of requirements within a straight MLOps environment. So what you get is you end up with a picture of a whole bunch of different capabilities. Central to it is a really, really robust model inventory. That model inventory needs to include a lot of information about like the source, the trained artifacts. In the case of a machine learning model, is absolutely we want to know that what data was used to train it. Excuse me. In the case of a then we need all the different kinds of monitoring. What monitoring is done in that? What inferences have this model actually made? Those all together. So, we're bringing together the development frameworks you see on the left, where we actually have all the different kinds of tools, as well as all of the different kinds of steps along the way. As I said, concentrated more at post-development, but, we really need to pull those together and make that all happen out there. And eventually, at the end, not only get those things deployed and there, but be able to report on all of those items that are out there. So, that's a key element of a model ops solution. So the kind of things we're trying to solve with model ops is like things like simple questions here. Like, well, how many models do I have out there? And, where are they running? How long have they been out there making these scores and things like that? Were they actually validated, security scanned, approved, all these kinds of things? Have they been tested? Excuse me. And, that. So, we seek to actually be able to provide that kind of what is actually executing out there, what has been running, what's the development process, and who approved these things, and all kinds of different things like that. And when do we get when these models no longer applicable and things like that. So to do that, we do what's called we like what we refer to as the model life cycle. And just a lot of MLOps is focused around training, retraining, and then the development life cycle. We really, when we look at the model life cycle development, but it's really what happens. Okay, now that they develop the model and they say it's good to go, how do we know what's in that model, how it was developed, what's its performance expectation, what's the next time, have we done bias checking, who's reviewed this, and all those things. So it goes way beyond your typical model development lifecycle, and can expand, in the simplest case, it could be hours where we're just doing some quality checks and getting out there, maybe doing some security, etc. things. But really, it could go on for months when we get into things like government regulation, where you've got to actually prove things like under the Frank Dodd Act, you get moved more than 3 times, I think it is, before it actually went into the model. I'm not sure, but that's the regulation. So when you come and you actually get audited on that, you have to be able to prove that. You have to have something to come back. So a model ops solution really goes out there to, make sure we not only document the process that it has to go through here, but actually then record the actual journey through that process, because there's obviously lots of forks and gates and all kinds of things that can go on that drive a model down different paths depending on how it was developed with and things like that. Like if it's a trained versus an untrained model, both be solving the same business problem, but you're not going to treat them exactly the same through that journey. So you'll see on the a full, and don't worry, we're going to zoom in on some of these areas to give you some examples of what's going on in there, because it's definitely we put that there to show you the idea of the breadth and depth that a model ops solution will actually deliver by making sure you move it through all these processes and record what's actually going on there, drive that. So, again, we do things like completeness analysis. And what I mean by that is things like, are all the pieces there? Are all the documents in place that should be there so we know what this model's doing? Do we have a reference to the training data? Do we have, all this kind of stuff? And that's typically the kind of things that a model op you want things like security compliance. Are you using the right Python library? You put one out there that could potentially have a vulnerability that's either has been addressed or hasn't been addressed, or those kinds of things like that. And then we want to ensure some quality and stability within the model. Then we'll talk. We're going to zoom in on those ones a little bit there, as well as things like environment promotion. Typically you may not want to throw a model just right out straight into production. You may want to run it in parallel for a while, or quite often you have a staging environment where you got to run for X number of days before we allow it to go on, and running in parallel on some subsets of the data, just to make sure that the the thing is performing correctly before we get it out of there. Because that's one of the key things here is with model ops, we're trying to not catch the problem after the fact. We're trying to prevent as much of the problems as we can in there. Yeah, and this is important in MLOps too, and why, things there is actually the model and data monitoring, looking at how is the model performing, what's it actually outputting, data, what we train on versus what we don't, or is the very nature of the data itself changed from one, well, probably may need to readdress that model and things like that. And likewise, going with that, we want to retire the model eventually. It probably has a life size. We know models degrade over time, so we need to manage that and make sure that, hey, is there one coming up, someone's gone, and be able to report on these kind of things, as well as we already briefly mentioned, integration with existing IT investments. Is going to be a big thing, so you got to drive that because likely if you're going to production, there probably is already a codified CI/CD process for moving the physical artifacts out onto the machine. Solution absolutely needs to play with those kinds of things and put it out there, as well as we've talked about the ticketing systems, but then there's also service alerts when things go wrong. That needs to go into an escalation system, getting that centralized reporting in the end, so we can look across all of these models running through different life cycles, because not every model is even going to follow the same life cycle. You may have multiple different ones at different times, because the reality is you may have one that's under government compliance that it takes a really long time to get them out of there, or it may have other ones that don't. That can be moved out there quicker. So an example of one of these life cycles, we can zoom in on, talk about model completeness. So here's an example, we make sure there's a drift where we actually have criteria set for what is considered out of spec on a drift. And likewise, we some smoke test data associated with the model, and check that there's actually the appropriate assets there, and that there's a descriptive document associated with the model and things like that. Likewise, we also and this is like literally when we developments of just doing some sanity checks. So we go and actually launch and run Veracode scans or those kinds of things, so we can actually look at the code for the security vulnerabilities and things like that, and do that. And then further do things like library version compliance, using libraries they're supposed to. Is are they using things that are out of spec, or introduce something that is finally use some of that test data and run a quick smoke test on it, and actually go through and actually run the model on the data to make sure it just doesn't fall over before we waste any reviewers' time. We can do all this through an automated process, and this is what MLOps does. It runs all of these, pushes these, and physically tracks every step. So you're not looking at just a documentation here. A MLOps solution needs to actually provide each and every single one of these steps in an automated fashion, and do that. That's so that when as soon as they check something in, it's kind of like unit tests. Okay, all the pieces are there, seems to build, seems to work. Same thing we need to do with a model, is make sure all that is there. Another example is not only monitoring, but well, what happens when we detect something? So a lot of MLOps stuff, they'll do monitor and may check something back, but realistically, we need to drive a whole process of like, hey, we've been looking at this model and we detected some data drift or concept drift, or okay, who do we contact and how do we replace this? We can't just auto assume rolling back a model is going to solve the problem if we get something there, because the old one may even be further drifted. We need to make sure that's actually addressed. It's addressed in a way we get a ticket created in the system for somebody to go out and look into it, so make an informed decision. We can track that they made a decision and get a new one promoted out, and make sure it's actually replaced, and that kind of thing. So a model needs to drive that whole process to actually make sure all of that actually occurs on that kind of things. Garden quote here about model ops is, it really does lie at the center of the enterprise AI strategy, because, basically we need to get all these platforms, artifacts, solutions, etc., coming together and make sure we can get them out there, that they scale to them, and more importantly, we can do something about it in the long run when it gets there. So, through doing that, we have that robust inventory about the models. We know when they were deployed, where they were deployed, what was in place making inferences at this time, what did it go through? Give me the bias reports, give me, all the explainability that went on there, and that kind of thing. That provides the transparency into what this model did. So if anybody actually questions the outcomes, have that whole lineage of the very, very granular details about how the model was actually built and designed, well as well as all the tests and explainability and bias and those kinds of things. And that, because really what we're trying to do then is then at the end, we catch things as before they go really wrong, and that's our risk control, where we actually go out and we can reproduce this model, we can retrain it, we know when it drifted, who did, and what went on there. Long run, what we need to do for the final part of a model op solution that's very important is enterprise-wide reporting. So we can actually assess our current risk, because not all the models in an organization may be up to spec yet. So, or we may need to know that we have a bunch of models that are ready to retire. They've been there too long. Do we have somebody working on it? What is our company risk behind our models? So, having that actual dashboard that looks across all of those, the MLOps solutions need to be able to pull into that data into standardized reporting tools, so it can be shared across the enterprise. So everybody can actually understand, and not necessarily just the data scientists, but your business have the KPIs and stuff in place to understand where are we at as an organization about the things. And without ModelOps orchestrating all of these processes and track the solution to do that, it gets very difficult to gather that information. So in ModelOps solutions as a they basically provide that transparency into the data on that kind of things to pull it across on that. So this provides us that ability to do that and provide that kind of reporting. Our own product integrates with things like Tableau and Power BI to actually be able to provide those, and we can provide standardized dashboards, but more importantly, those dashboards need to be customizable to your business. And that's why we personally chose to actually integrate with existing BI tools to allow that kind of customizability. I'll just kind of leave the final quote here about why this is becoming so important. Both the Federal Trade Commission and the EU have recently come out with some pretty strong statements, especially about AI algorithms. I'll just read this one off because it's so important, which is, as we know, it's important to hold yourself accountable for your algorithm's performance. Our recommendations for trans events can help you do that, but keep in mind that if you don't hold yourself accountable, the FTC may do it for you. So that's a pretty strong statement where you don't want to expose your company to that kind of liability. So you need some kind of a model op solution in place to ensure that these models have the quality, the transparency, etc., that these organizations actually expect. So now I know I'll open it up to a few questions.
Thank you, Jim, for the insightful talk. Yep. So we do have a bit of time for a couple questions. So if you have any, please type in chat right now. To start off, we have a question about how to monitor the performance of the model.
Just 1 second, Peter. There we go. Now I got you. All right.
Yeah. All right. Awesome. So our first question is a question about how to monitor the performance of a model and what tools could we use to monitor the performance, and how do we integrate that to DevOps?
Okay. Yeah, excellent questions. That's basically, I'm going to refer directly to our solution just because they're all different, because ModelOps as a concept says to go do that. But in our solution, for instance, what we do is we actually packaging of monitoring models. So for instance, we have ones written already for things like concept drift, data drift, etc., and that kind of things. But we do it through what we call an associated model. So you can actually write your own from scratch if you have customers and say, hey, this is the monitoring model for model B or whatever, model foo, and that kind of things. And then we can run that on a scheduled basis. And then what we do is we use decision tables or DMNs that can be associated with that particular model that says, hey, if you don't meet these criteria, so we use decision tables for that because you could have 15 scores and you want to do some kind of sophisticated comparison there. Then we can actually trigger an action, and that's those model life cycles we talk about. So that's where it could go out. It could create a ticket. It could trigger a CI/CD deployment by launching a Jenkins job. That basically, that's one of the powers of having a flexible model lifecycle rather than being hard coded. Use BPMN 2.0 to actually define those, and then we have high-level tasks drag and drop together to actually lay that out. And then we believe that's one of our differentiators as a product is that yes, we can trigger CI/CD, we can trigger a ticket, we can trigger an alert to a system, and it's really important to make sure. Okay, great, you sent an alert. Well, did it get a result? So you want to make sure that it has that full pattern. Answer your question.
Yeah. I think it seems like ModelOp has like a very robust solution to handling performance that is also sounds quite automated as well. So and has actionable outcomes, right?
Absolutely.
So I guess a follow up to that question is so it's about bit more about platform specifics. So if we use SageMaker, is it possible to monitor the models using AWS CloudWatch or ModelOp?
Yeah, actually, with ModelOp, we with SageMaker. So we do actually do exactly that. We tie into CloudWatch, and we actually can gather any of that. We also can look at the statistics contained within the training job itself, report those or whatever, and those can be used absolutely as triggers to trigger our model life cycles. And in fact, then we can talk back to SageMaker and do other things as well. So it's a kind of a two-way street where we do that. You just basically place the model under monitoring within our tracking it, and then we start that live integration nonstop where we do actually do all of that and can instantiate basically any kind of activity within the organization.
Wow, that's very in depth and quite amazing. So I guess next question is it's more so of a higher level question. In terms of from your experience, what are some of the biggest hurdles businesses have, especially enterprises where they have thousands of models in production already, in terms of developing or implementing model ops in their workflow?
First, the biggest hurdle is, and we help customers with this all the time, is actually identifying what your process is and what it actually understanding like what kind of a model lifecycle makes sense for a given company, given the fact that they often it's kind of ad hoc and there's 15 groups doing it 15 different ways. So getting that actually documented, and our tool helps do that because of the process you do that. And then it's a matter of actually using our tool to then automate that. And model ops will, just as a concept, will help you do that, because now that you've described how it either is or should be, well, then it becomes a lot easier to actually follow it, because then you have the tools and the methodologies to actually communicate to your business how things should be done, and you can kind of get that delta of where you're at versus where you're not, and then you're headed down the path, and then it can go very quickly from there. And that first big hurdle is not only deciding how it is, but how it should be.
I see. So yeah. So we have a couple more questions. How do we determine the models are obsolete? Is it we can say since it's been 6 months or a year, can we make the models obsolete? So how do we determine when the model's life cycle is over?
Yeah, well, we approach that through the idea of an expiry date, where we consider the model retired. And that can be defined within the system. We also have an option. So for instance, our solution is not just absolutely can be containers, but we do actually have the ability, we have a runtime where you can dynamically deploy a model into, being Python, R, C, PFA, PMML, so that you don't have to have a container per model, so that you can actually just deploy that model code and keep the one container and then upgrade without actually having to do that. Container, the way we do that is we actually have a reference along with all the source code and etc. to that exact container instance, and then we can actually say, hey, on this date we consider this model expired, and we've implemented that with several customers where they a model is done at this date and should not be used, and you can trigger all kinds of warnings that that's coming up beforehand, etc. as well.
Mm-hmm. And on the topic of containers, so when there's too many models in production, if the container is used, which causes container mess, which can contribute towards technical debt. What do you think is best practice to reduce that?
Well, the best practices is definitely have that expiry date, so we can remove those after a while. I personally believe the best practice is to not necessarily tie your models to a container. Ideally, you can deploy them into a common runtime container, like we have available, so that you don't have to just have container for version of the model. Instead, you have a container that represents a runtime environment. on AWS, you pick a certain container from a small set of containers and you deploy your software onto it. That's in fact the model that we think is the absolute best practice, which is to do that. We absolutely support both, and any ModelOps solution needs to handle that. But ideally, you don't have to have a full container for every single model out there. You can say, hey, here's a model container to run that model on. Oh, there's a runtime with that container already out there. We will go and place ourselves on there.
Mm-hmm. So in terms of how can machine learning teams develop reusable models spanning different business objectives so that they can reuse across the organization?
Yeah, well, that's the model inventory comes in, because you can see the kind. For instance, I can see what data set this was trained on, so it's likely it says similar to that. I can do that by also having model documentation within the inventory, so you understand what the model is actually trying to do, et cetera. And there, that's the whole concept of a model catalog. We kind of take it a step further, and that we refer to as more as like a model inventory, because we're capturing a heck of a lot more data than just its use pattern. You can see who did it, what it's been tested on, what data sets it supports, et cetera, and that kind of thing. So the biggest thing is getting it documented, getting it centrally accessible, and making sure people understand what went into that model.
So it seems like there's a lot of work to just make sure things, a lot of the models are not siloed in a sense as well.
Yeah, and that's where the ModelOps solution can ensure that by doing what, the completeness check up front, making sure that there's adequate documentation. It's in the agile terms, it's the definition of done. We need to actually make sure we track and enforce that. Solution, so we can say, hey, we don't know enough about this model. Could you please go back and add some documentation here and help the developers do that, because we all get busy. We forget. It's nice to have a system that helps ensure that kind of quality.
Mm-hmm. Okay. Yeah. So I think that should be all for the questions. I hope all your questions have been answered in chat. But thank you so much, Jim, and thank you everyone for joining us today.
Yeah, thank you everyone. And I enjoyed it, and I hope you did too.